We present a system that gives users control of the detailed elements of laser cutting, such as individual plates and the associated joints. Yet at the same time also allows for efficient editing by using volumetric tools, while preserving the structure of the plates in the model. Let me show you how modeling this guitar requires us to deal with volumetric as well as plate-based elements. The body of the guitar is a volumetric object, so it's best created using volumetric tools. The more detailed structure of the neck does not lend itself well to be represented as a volume, but instead consists of individual plate elements. We added another subsystem that allows us to deal with plate-based elements. So now we have a body which is volumetric and built on a volumetric data structure. And we have a neck which consists of plates and uses a different data structure. How do we bring those together? Let me build another neck. I will start with the volumetric tools and see what obstacles I ran into and how to overcome them. I want to remove these plates here in the front, but then it cannot be represented as a closed volume anymore. This is possible in our system though. What happens under the hood is that the moment I click this plate, the system internally switches out the volumetric representation with an explicit 3D construction of plates. And that then allows me to move forwards and actually delete these plates, a mechanism we call demotion. To form the neck, I would like it if all these plates extend at the same time. I would like to think of all of these plates as one, so essentially a volumetric element. Our system actually allows us to do that. The moment I attempt to stretch this with the volumetric stretch tool, I modify all plates at the same time. What happened under the hood is that the system recognized that this is similar to a volume, and it thus switches to a volumetric representation. We call this process promotion. As I continue modeling this guitar, I go through perpetual sequences of promotion and demotion, which allow me to use the different tools on the model at all times. So our system consists of a volume-based subsystem taken from kyub. And we designed and built a plate-based subsystem as an extension, together with a set of tools that allow us to modify plate-based structures. To allow plate tools to apply to volumes, we change the underlying representations using demotion. And we allow volumetric tools to apply to plates using promotion. Let's look at the implementation of the plate subsystem, the promotion mechanism and the demotion mechanism. We have designed and implemented 10 tools that closely follow the interaction style of their volumetric counterparts. This allows for simple interaction, as the tools applied to volumes perform the same functionality when used on plates. Let's look at the underlying data structures and algorithms behind the promotion and demotion mechanisms. This voxel is internally represented as a mesh that consists of 6 faces, which are the plates in the model. Each of these faces have edges that connect to one another, and together those form the points that make up the mesh. The edges form a closed cycle in the graph as they all connect to one another. During volumetric operations, the assumption of that closed cycle ensures all plates are modified accordingly. When I delete one such plate, the demotion mechanism breaks up that cycle and represents these faces as individual plates in 3D. They now have their own coordinate system and thus can be modified independent of one another. The promotion algorithm works the other way around, by incrementally grouping together adjacent plates in a flat fill fashion. However, if there are still edges that are not connected to other edges, the algorithm constructs proxy planes to close the volume, and adds missing vertices where those planes intersect. These vertices and proxy planes then close the cycle, allowing volumetric tools to apply, even to deformed structures as shown here. We used our system to recreate 100 models of a benchmark of laser cut models. Our system allowed recreating 87 of these, compared to 15 using a plate-based environment, flat fab, and 9 using a volumetric environment, kyub. We presented a system that allows users to manipulate laser cut models in detail by editing individual plates, as well as efficiently, by editing entire groups of plates considered a volume. We achieved this by starting with a volume-based system, kyub, and adding a plate-based subsystem with its own set of 10 tools. We then built a mechanism that allows plate tools to generally apply, we call demotion, as well as a mechanism to allow volume tools to apply, we call promotion. The integration of volume-based and plate-based editing allows us to process more complex models than previous systems.